Download this code from codegive.com, link in the description below. OK, let's dive into dynamic module imports in JavaScript. This is a powerful feature that allows you to load JavaScript modules on demand, rather than all upfront. This can significantly improve performance and user experience, especially for larger applications. We'll cover the concepts, syntax, benefits, drawbacks, and real-world examples, all in the spirit of a comprehensive Lecture 46. Lecture 46, Dynamic Module Imports in JavaScript. Introduction. Traditionally, JavaScript modules were loaded statically. This means that when your JavaScript code was parsed and executed, all import statements at the top of your file were resolved and loaded immediately. While this works well for many scenarios, it can lead to performance bottlenecks if you're loading code that isn't immediately needed. Dynamic imports, introduced in ES 2020, ES 11, provide a way to defer the loading of modules until they are actually required. This approach offers several advantages, which we'll explore. Key concepts. 1. Static versus dynamic imports. Static imports, import, from, these are declared at the top of your file. They are parsed and loaded before any of your code executes. They must be at the top level of your module. They cannot be used inside functions, if statements, or other control flow structures. Dynamic imports, import, these are invoked as a function using the import syntax. They return a promise that resolves with the module's exports when the module has been loaded and evaluated. They can be used anywhere in your code, including inside functions, if statements, loops, and event handlers. 2. Import, function asterisk. The core of dynamic imports is the import function. It takes a single argument, the specifier of the module you want to load. The specifier is typically a string representing the module's path. It can be *relative path, ./module.js, /util/helpers.js. *absolute path, /module/mymodule.js. *package name, if using a module bundler like Webpack or Parcel-Ladesh. The import function returns a promise that resolves to a module object when the module has been successfully loaded. The module object contains all of the exported members of the module, functions, variables, classes, etc. 3. Promises and async/await asterisk. Because import returns a promise, you'll typically use async/await or .then to handle the loaded module and access its exports. Async/await is generally cleaner and easier to read. 4. Module object asterisk. When the promise from import resolves, it provides you with a module object. This object is like a container holding all of the things that the imported module has exported. You can access the exports using dot notation, example module.myfunction, or destructuring. Syntax and examples. Let's start with a simple example. Now, let's dynamically import this module. Explanation asterisk. 1. Async function load and use module, asterisk. We wrap the dynamic import in an async function. This allows us to use await. 2. Await import, ./mymodule.js, asterisk. This is where the dynamic import happens. Import, ./mymodule.js, returns a promise. Await pauses the execution of the load and use module function until the promise resolves, i.e., the module is loaded. 3. Const module equals, asterisk. When the promise resolves, the module object is assigned to the module variable. 4. Module.greet, Alice, and module.py*. We access the greet function and the py constant exported from myModule.js using dot notation on the module object. 5. Try, catch*. It's crucial to wrap dynamic imports in a try, catch block to handle potential errors during module loading. Example: the module file doesn't exist, there's a syntax error in the module. Using .then, instead of async/await. If you prefer not to use async/await, you can use .then. Conditional module loading. One of the biggest advantages of dynamic imports is the ability to load modules conditionally. Explanation ***. The load feature function takes a feature name as input. It uses an if/else structure to determine the correct module path based on the feature name. Only the module corresponding to the selected feature is loaded, reducing initial load time. The initialize function is called in each module to start the feature, ensuring that the module's code gets executed. Real-world use cases. 1. Code splitting ** break your application into smaller chunks, modules, and load only the modules needed for a specific page or feature. This significantly reduces the initial download size, improving the perceived performance of your application. This is huge for large SPAs, single-page applications. 2. On-demand loading of components * in UI frameworks like React, Vue, or Angular, you can dynamically load components when they are needed, example when a user clicks a button or navigates to a specific route. 3. Plugin systems * allow users or developers to extend your application by adding plugins. Plugins can be loaded dynamically, providing a modular and extensible architecture. 4. Language packs / localization * load language-specific modules dynamically based on the user's locale. 5. Polyfills * load polyfills only for browsers that need them. For example, you might load a polyfill for fetch only if the browser doesn't natively support it. 6. Loading based on device type * load different modules if the user is using a mobile device versus a desktop to optimize performance. Benefits of dynamic imports. Improved initial load time * by loading only the necessary modules initially, you can significantly reduce the time it takes for the browser to download and parse your JavaScript code. Reduced memory footprint * loading only the modules that are needed reduces the amount of memory used by your application. Code splitting * easier to split your code into smaller, more manageable chunks. Conditional loading * load modules based on conditions, example user role, browser type, feature flags. Better user experience * faster initial load times translate to a better user experience, especially on slower networks or devices. Drawbacks of dynamic imports. Increased complexity * dynamic imports add complexity to your code base. You need to handle promises and manage the loading state of modules. Potential for errors * if you load modules dynamically, there's a risk that a module might fail to load, which can lead to errors. You need to handle these errors gracefully using try, catch blocks. Bundler configuration * for complex projects, you often need to configure your module bundler, like Webpack, Parcel, or Rollup, to handle dynamic imports correctly. Bundlers analyze your code and create optimized bundles for deployment. They need to be aware of dynamic imports to split your code into appropriate chunks. Potential for race conditions * if you load modules dynamically and rely on them in a specific order, you need to be careful to avoid race conditions. This can be mitigated with proper promise chaining or async/await control flow. Module bundler configuration, example with Webpack. Most modern JavaScript projects use a module bundler like Webpack. To take full advantage of dynamic imports, you'll need to configure your bundler. Here's a simplified example of how to enable code splitting with Webpack. Explanation of Webpack configuration **** split chunks, this is the key option for code splitting. ***chunks, all this means that Webpack will automatically split chunks for both initial, static imports, and async, dynamic imports, modules. Async only splits chunks from dynamic imports. * cache groups, this allows you to configure how chunks are created. The example creates a vendor chunk that contains code from node_modules. This can improve caching because vendor code changes less frequently than your application code. With this configuration, Webpack will automatically create separate chunks for dynamically imported modules, which will be loaded on demand by the browser. The output file names will vary based on the specific Webpack configuration. You might use name.bundle.js to have file names that reflect the module names. Tips and best practices. * use try, catch * always wrap dynamic imports in try, catch blocks to handle potential errors. * clear naming * when using Webpack, use comments above the import call to help give the files meaningful names in the DevTools. This will output a file called myspecialmodule.bundle.js rather than a generated name. * consider a loading indicator * when loading modules dynamically, display a loading indicator to provide feedback to the user. * careful planning * plan your module structure carefully to optimize for code splitting. * test thoroughly * test your application thoroughly to ensure that dynamic imports are working correctly in all browsers and devices. * monitor performance * use browser developer tools or performance monitoring tools to track the performance of your application and identify areas for improvement. * be mindful of security * when loading modules dynamically from external sources, be extremely cautious about security. Verify the integrity of the modules before loading them. Browser compatibility. Dynamic imports are widely supported in modern browsers. However, older browsers may require a polyfill or transpilation. Tools like Babel can transform dynamic imports into code that works in older browsers. Conclusion. Dynamic module imports are a powerful tool for improving the performance and scalability of JavaScript applications. By loading modules on demand, you can reduce initial load times, improve the user experience, and create more modular and maintainable code. While they add some complexity, the benefits often outweigh the drawbacks, especially for large and complex projects. Mastering dynamic imports is a key skill for modern JavaScript developers. By combining them with appropriate module bundler configurations, you can deliver fast and efficient web applications.